The Google Plus discussion group, Leroy runs that. It's been cooking along here for a few months, getting, I think, a little more popular. Vicente is a good publisher there,
I knew one.
and Leroy and I and whoever's interested. So we got a link to that if you want to see what we're doing there. Or if you want to submit articles, feel free. Sign up. Leroy will get you in. That's our official meeting time. Starts at 5:30. We're here typically from 5 to 5:30.
This will be the real chassis.
And we're out of here by 7.
Yeah, by 7.
7. Okay,
Yeah.
On the dot.
On the dot. Use the Gestapo. I'm the Gestapo. I will come in at about 5 minutes to 7.
Cut your hand off. You don't.
Get out of there. Pack your stuff up. Start packing your stuff up. And I'll turn the light off a couple minutes early. So
He has the alarm go off 5 minutes before, just
to make sure.
All right.
So we're good customers.
You don't want to
Freeloaders, as the case may be, for the library. So we respect their wishes. So you'll find me herding people out of here and try to come in on time. Leroy was in early today, which is good. I guess during the summer they give us some slack.
I came in and watched TV.
But we got in trouble previously for that, but okay, that's good.
For watching TV?
For coming in early.
Oh.
Coming in a minute early. Asking them to come in a minute.
I didn't ask. They just opened the door. So.
Oh, okay. All right.
So even though the meeting starts at 5:30, let you break in or come in here at 5.
Well, we officially, to them, we start at 5.
Okay, I got you. But
And we have an informal session until
I didn't know
5:30.
that. I did not know.
Now,
I thought it was 5:30.
that's what this briefing is about. So
if I saunter in at 10 after 5, just come on back.
Yeah. And even
And
if,
knowing is half the battle.
and yeah,
That's right.
we say that typically the room is open at 5, and the meeting officially starts at 5:30, and that's fine. And we encourage people to come in late. Okay, if you want to come in late, that's good. We appreciate that. Frank, who will probably be here shortly, maybe. Jeremy.
He comes in a little.
Come in late. And,
Oh, they're working traffic.
and we appreciate that because people have jobs. I've heard. Rumor
I know.
Was that right?
What's a job?
What is your retirement?
Right.
But I got disability. I was a school treasurer. I was in SERS retirement system. So I got early disability. So I don't know crap about technology, but a lot of my family does. So like I said, I like hanging out I go to the CLUG, Steve Jones comes here now. I told him about this. And he's the president of Linux Cincinnati. And he is really smart.
Yeah.
He's a smart guy.
Don't put these guys. Don't say that around here because we got some smart people sitting right in this room right now.
I
Not
know.
me.
So where does the Cincinnati Linux group meet?
Well, right now we're meeting at the Norwood Library
I have no idea.
on Saturday on Montgomery Road. You know,
I'll send an email to him.
we were
if
meeting
you
at the
want.
Pleasant Ridge Library, and then we were meeting at Molly Malone's so we kind of go different places.
He's got a website.
But we usually meet once a month.
Oh, so they don't meet weekly or anything?
They may have a special meeting, but they at least have a once a month meeting, usually on Saturday.
Some people say we meet weekly, but I'm not sure what they mean.
Now there's another group.
Spelling.
There's another
Spelling could be
group
different.
called the D-Lug group in Dayton, and they meet up near Wright State. And they're a bigger group. They got more.
What time do you meet on Saturday?
Anywhere from 10:30 to 11:30, and it usually goes to like an hour and a half. And then there's a place called Gordo's right across the street. They do burgers, beer. So we went there. This is right in Norwood, right on the main
Montgomery Road.
We met there last week. And like I said, we've met at Pleasant Ridge Library there in Pleasant Ridge. And then there's a place called Molly Malone's that we meet. So he moves it around.
The CLUG URL is?
If you Google clug.org, Steve Jones is the president. He runs the website and everything.
Yeah, C-Lug, Cincinnati.
C-Lug,
You'll
Cincinnati,
find him.
and Steve Jones.
Yeah.
He runs the
I did.
website.
I didn't realize.
And there are a lot of smart guys in that group too, I'm telling you.
So what do they typically do? They have presentations or what?
What was that? He does the, it's called NetSphere. He did a demo on that.
Mhm.
And I'm gonna start trying to build my own. But he'll do stuff. There's a guy named Dave Herman. He came in and did some programming, showed some programming, let statements. And we're talking about having an install fest one of these days too, but we've never done. Now Dayton has a big install fest with the Makers Group up in Dayton. They do that in the spring usually. A lot of times there's a big Linux meeting in Indianapolis and there's one in Columbus. They'll go to that
There's
too.
one in Columbus.
Yeah, I know about C-Lug in Columbus.
But there's a bunch of IT tech guys in that. I'm just learning it. I was in the Windows world and I got tired of Windows being slow and then wanting to load everything. So my friend told me about Linux and I started learning about when I took a class at Sinclair. It's not fancy, but I'll tell you what, it runs like a bar on a, you can run that on a barbed wire fence, you know, Linux.
Well, the nice thing is you can take some really old hardware and load up,
Yeah.
take your choice of distributions and you end up with a much higher performance computer. So, yeah.
Steve runs Ubuntu, but he runs Mint.
Yeah.
Some Mint stuff.
That's Ubuntu with training wheels.
Yeah.
Okay, well, we better get started since we're officially into the startup time.
Okay.
Who's on?
Vicente is this week.
I was forced to bring my stuff because it's not finished.
Okay.
It's a work on
I didn't force you.
here. Someone
Yeah, blame
put
me,
it.
sure. I'll take it.
Okay, I will connect the Chromecast.
You want to see the video up there? You want me to show them the video?
I have the video. I was planning to show the how this started two months ago when
Okay.
Ray is another member of the club and he bring us several stepper motors with gear reduction. Okay, very small one motor, and we were talking about to use it for a robot, but those stepper motor has a lot of reduction and they are very slow to move wheels, you know.
Yeah.
Then I began planning to design a bigger wheel and to apply more voltage to the motor to has enough torque to use in a robot, right? I started looking for a O-ring, rubber O-ring of a reasonable size. I found in internet, in AliExpress, I found the O-ring of 117 millimeters diameter and decided to use this size to design the wheel, right?
This all started out with Leroy's demo, and we're having a consideration with how the angle that it turned and how many steps and how straight it went.
Yeah, yes.
And then we digressed into stepper motors, because stepper motors work, and Vicente took it from there.
Yeah.
So is this a 360 stepper or 180 stepper or?
180? No, it's a full.
360 stepper
Yeah,
motor.
it's not a servo. It's a stepper.
It's geared.
You can go on.
Yeah, well, stepper motors can be 180 also. So, so this is 360 continuous. You can step around as many times as you want to.
Yeah.
Okay.
Yeah.
You can go in any direction, any steps. You go slow, you have a lot of torque. You try to go fast,
Is that
You-
done
you
with a
lose
laser
30.
printer?
Yeah, that's laser cut.
That
Laser,
carbon,
yes,
is
laser.
that carbon?
No, it's
Acrylic.
Plastic.
polyethylene, the same one that is using Ray.
Ray original was acrylic, and now he's gone to what?
Well, the new
Poly-
robots are
poly-
styrene.
Styrene.
Polystyrene, yes, this is styrene,
Styrene.
Oh, okay.
black styrene.
These are cut. These
Yes.
cut.
I use three layers to assemble this wheel. This is an example. The final design of the wheel is this one.
You have a laser cutter.
Laser cutter and glue it together, 3 layers.
Okay. So these are.
So you don't glue it
Built
together and
by
cut it,
hand.
you cut
Those
them
are
and
no
then glue
glue.
it
Those are
together.
with the screw. I'm putting together.
But now this is not 3 layers.
No, this is a single layer.
Yeah. And this is using CO2 laser, I assume.
No, laser 80 watts.
I'm sorry?
80 watts of power. A
80
laser.
watts.
Yeah, but what kind of a laser is it?
It's a stable.
CO2.
Huh?
CO2
Is
laser.
it CO2? Is it
CO2, yes,
YAG?
the
Is it
glasses, yes.
Exmer? What is it?
It's a glass tube behind the machine,
You're
CO2.
talking
doesn't
about
know.
CO2.
CO2.
cooled by water.
Okay. So this is the same kind of laser as Ray sells?
Yeah.
That's a CO2 laser.
Yeah.
I have 2 of them, but
It's
those-
10.02
mine's are
Ray's the
big.
guy that has that place out near Germantown and Middletown.
Yes.
There's Frank.
Hey there.
Speaking
This is
of
the late Frank.
the late Frank.
The late, but still.
I use wood because I like woodworking, and I pretty fast cutting things, you know. And instead of design a new shape of the chassis, I just cut some woods to demonstrate how it works, right?
Besides which, it's got a nice rustic look, you know.
No, but I used to design the wood shape in AutoCAD, print on scale on paper, use the spray glue on the wood, apply the paper, and then cut and drill all the holes,
Oh, okay.
and then sand the paper out, and it's perfect.
So that's the way you get rid of the burnt edges is with sandpaper?
No, this was with a saw.
Oh, this is not laser cut then?
No, so, by hand. Well,
Okay.
using several tools. I have all the tools of woodworking.
Got it.
Anyway, I changed this because how the wheel is connected to the motor. When you install the how you call the piece that
The hub?
The mount.
yeah, the mounting
Yeah. The bracket.
you can
So
put
is
the
this
wheel
the way it goes?
only in this direction, and you need to move the wheel in this direction to fit to the motor.
That was probably an earlier iteration.
Yes, the different iterations of the same design.
So you cut 3 layers and then bond them together, or you cut
Yes.
them all,
Cut and bond.
cut and bond in that order? You don't put them all together and then cut them all simultaneously?
I made several three wheels of different sizes.
Mhm.
To the outside sizes is a little bigger than the inner.
Ah,
You know,
okay.
then using a Dremel tool to make the chaflan.
Okay, so that's how you get this gizmo right here.
Yeah, I made
That's how
I
you
made it
differentiate.
different sizes on purpose. Okay.
Yeah, right.
Just
So
to-
that when you put
Yeah,
them
for aesthetic
together,
reasons. Okay.
you get that nice stepped.
Yep.
Yeah.
That's pretty
Yeah.
cool.
I can show you a document that I was writing all
And then
the
this
steps.
This is just an O-ring, I assume, right?
This is a guitar cable. Okay. It's almost pure rubber.
Oh, it's what?
Just pull the wire out of the cable.
It's an insulator for a cage.
I was waiting for the O-rings from China, but never came. I'm-
So you
I'm-
MacGyvered it together.
That's something like that.
So how do you bond the ends?
That is a real problem. I show you how everything happens in a document. Let me show.
That's a pretty good
I learned a lot of
change by
things.
necessity.
That's ingenious.
I thought that was an O-ring, maybe, didn't I?
Well, that's what I figured it was. It was an
Yeah.
O-ring you
Yeah.
flipped on.
I bought this thing from Amazon in continuous,
Yeah.
and you can glue this with crazy glue. Okay, this one.
Yeah.
But the cable is made of some kind of silicone, and was impossible to use crazy glue for that.
Yep.
Then I found a special glue from Loctite
Yeah,
that use a special treatment in the glue.
Yeah.
You change the surface of the material
yeah.
before gluing,
It'll
Yeah.
fuse
and works
together.
great. Works. Perfect.
Wow.
Ingenious.
Loctite, I thought was cyanoacrylate.
They say the name of the glue is plastic. I'll show you. I have records of everything.
Click on share. Yep.
Okay.
So you just have to
You
cut
should.
that length
There you
just
go.
perfectly. If you don't get
Give
that
him a
length,
little
if you
nudge.
don't get that length perfect, man.
No, I made a piece of wood to do that.
Oh,
Okay, like
you have
a slot in a
basically
piece of
you
wood.
have
64,
mechanical
so
jig that you
128.
Yes, I
Template.
cut a quarter-inch wide slot to cut and put straight the glue, and you wait for a minute, and then it's very strong.
just got to keep your fingers clear.
Yeah, that was some exacto. Okay, this is the history,
Cool little stepper.
how it happens. Okay,
Do you have any idea how many steps this is?
okay, it's
What are they, 18?
2048 steps per revolution. Okay, because it has a year reduction.
So they're micro-stepping that, okay.
No, microstepping is an electronic, it's signaling in the
Yeah, I
coils.
know.
But this,
But
I
you can
can use
micro-step,
microstepping because you reduce more the advance with the very tiny movement. Okay, this was the 27 April meeting when Ray brings the motors.
I usually have to do it on my pant leg. His mouse isn't working real well.
oh, it doesn't work on this surface?
Because it's too slick.
Okay,
Well, I hate to tell you this, but there are mouse pads you can
Get
use.
Vincente, maybe this cardboard if you.
what do you need?
For your mouse pad.
I don't know what's going on with this. Never happened before.
It's got more,
But never
I've got
happened.
a client who's got all
No,
glass
it's
table.
something.
yeah.
Oh my
Talk about
God.
frustrating.
It's the library effect.
It's just the library.
Yeah, usually you can put something like this table won't work, but you can put a
I usually
notebook or you can
Oh,
use
yeah.
your leg.
I usually use my leg.
One of the things about the club, Mark, is we're a P&A organization. You know what P&A is? Positive mental attitude. We're not allowed to say
No
the
negative vibes
thing.
in Moriarty.
No negative vibes to the guy doing the demo.
Always
Be
with the negative
supportive.
vibes. Kelly's here if you're seeing this.
Use the back of a legal pad, that'll also work.
Yeah.
Okay, I start everything with the motors that Ray brings, and he gave me 2 motors with the drivers. Okay, those the driver is unipolar. Okay,
Yeah.
so you only drive one side of the coil on off. Later, I will show how I am driving it bipolar to increase the torque and the speed. The first thing I did was to look for a big O-ring to design a new wheel, a bigger wheel for the, okay. Well, I end with this initial shape of the wheel, and then made a more appealing design. and the wheel is made of 3 layers of 2 millimeters of plastic. Okay.
How'd you cut the plastic?
Huh?
How'd you cut
With
it?
laser cutter.
Oh.
I have laser cutter in Caracas, not here. I made the initial design of the robot. This is the chassis, the chassis, the wheels, and all the parts are drawn to figure out the dimension of all the design, right? I made all the parts and started. This is from Amazon. This is the steering wheel. This is the first assembly of the parts. The problem with this chassis is that you need to assemble the wheel with the motor before fix the motor to the chassis.
Yeah.
Then I decided to use the wood part just for advancing, putting and removing different wheels, the design.
So the wood is
I-
just a model then, basically.
Excuse me?
The wood is a model.
A model, it's a prototype.
Prototype,
Template,
yes.
yeah.
It's a. Yeah. Sorry for my language. Okay, I can read and write, but I have trouble speaking. Okay, I found this in Amazon. They sell the O-ring this way and bought the glue and I made this O-rings instead of wait for the O-rings from China.
Oh, you took an O-ring, cut it, and then recut it to give you the right diameter?
Yeah, I just put the O-ring around the wheel and make a
Glue it
mark
together.
and maybe 3 millimeters less to make
Yeah.
it strong.
So that's
Well,
just a
everything-
cord called button O-ring. You can, that's a cord that
You can make O-rings with this cord, yeah.
I do that. I got on my pool. I have some of them that are that
I
exact technique. You put them a little bit too long.
I didn't believe that this
Works
is strong, but I tried after 3 minutes.
Yeah.
You can split the glue. It's incredible. It's very, very strong.
They are.
It's okay.
So you just go a little long on your pool thing to make sure you got coverage?
Yep, a little too long. Fit them in there. They're great.
Okay. I made I don't know the name of the diagonal when you cut the corners with
Talking
a
about bevels,
A miter.
a bevel or a miter?
remove the bevel with a Dremel tool. Okay.
Yeah.
Oh, okay.
I use this glue for this plastic, special for this plastic. There is a glue. You can use acetone or other stuff, but this is maybe acetone with some stuff, but to make a commercial brand about. I use screws to maintain the 3 layers together, and then remove them. I have the holes just for alignment, right? Use the screws.
So you just use those holes to clamp the 3 together.
Yeah,
And
I
then you
just,
take the
the holes
screws
are
off.
for alignment. I put them the design there for alignment. Ray, when I talked to Ray about the idea, he suggests to use a thicker plastic, okay,
Mhm.
and to route the V shape in the border, okay. But at the moment, I didn't have the right tool to do that. I use what I have at hand. Okay, this is the O-rings. You can see the small piece of wood to align the rubber here, right? A piece of paper, a very like toilet paper, because after you just put in the water and remove the paper with the extra glue.
Just tissue paper will work.
Yes. Okay, and this is the first try The first experiment was to find out what is the maximum speed that I can have with this driver design. I use 9 volts in the power supply. The motor is 4 or 5 volts. It's important in this motor when you use a battery power to turn off all the coils after the movement. If not, you will drain the batteries pretty fast.
How hot do the stepper motors get?
Well, if you turn off every time you move, you never feel the
You don't feel any heat at all?
No. Yes,
Interesting.
pretty cool. This is the first experiment. I put several videos in Google Chrome. I am publishing in Google Plus the videos, but I don't have this. This is my Google Plus account. Here's where we put all the stuff. Mainly Jim, Leroy, and me are the only people that is pushing content. Okay,
We're starting to propagate it because I think it's a great collaboration tool.
yes,
Leroy
I
came up
am
with the
every day.
idea.
I put something here in the. This is the first test of the model.
Where'd you get the music?
This is free. This is the
Oh, is that Star Wars?
Certainly sounded like it.
Yeah.
Okay, and here you can see this is a test made in the floor to check the precision of the movement.
Some waltz music.
Yep.
2001, it's Space Odyssey. Of course, that's not what this is.
I just changed the displacement to fit in this table with the.
Perfecto.
That's something else.
Very good.
Right in the square.
And that we're talking about accuracy originally.
But I need to adjust a lot of stuff.
This is right up your alley, ain't it?
Trash
Oh,
can,
yeah.
trash can.
Transport.
It's,
Yeah.
it's slow enough. You can make it go slow enough.
He's got a project to move his trash cans to the end of the driveway.
Nice.
Let's continue with the. Okay, this is when I found this cable in MCM Electronics. I saw 1/4 inch diameter. Okay, this is.
He's bad. He's bad to free
Looks nice and it's cheap to make the wheels also.
Looks good.
Now you can design any size of wheel. I don't have the laser cutter here in USA, and I can use wood and cut wood and do the same thing. Then a good thing is to use this piece of metal because the plastic is stable when you connect to the motor. I designed these flanges using cabinet knobs from Home Depot. Okay.
Okay. I look familiar now that you mentioned it.
Cabinet knobs right here.
I bought several stuff from Amazon to make the holes. This piece of metal let you to find the exact center of the of the hole in this part, right?
Okay.
And both this tool to make the thread of the
Okay, threading tool.
yes. This is the this cost $1.18 or something like that. It's cheap.
We have a propensity for cheapness here. Some of us.
There is.
I used to go to Home Depot and try to
Oh, cool.
Some more than others.
Yeah.
use the other stuff. When you are looking for something specifically for your need, the cost is high, but you can buy another thing that is the same material, same size, and produce another another piece or another.
So I do have a question, Vicente. On the video that you showed where it went to 6,000 steps and came back to the same, did you turn off the holding torque, the current on each step, or did you leave the?
No, at the end, I wait for a second and turn off all the coils.
Not at the end, but in the intermediate time,
No.
you kept it going.
Yeah. I wait 1 second in every corner. Between each movement, move forward, wait a second, turn, wait a second, move forward.
So he takes it to 0 and then waits a second, turns power on.
Wait. You can avoid waiting.
But you're talking about per step. You were asking about per step, right?
No, at each, at the end of each,
Second.
At each turn.
Run.
at the end of each move.
Is that how you keep the
No.
stuff cooled down?
I just keep energizing the.
You kept it energized the whole time.
Yeah.
Yeah, and the 1 second was between moves.
Yeah. But
It
if
makes a
you
move,
want to
turns it
stay
off.
quiet for a while, it's better to turn off because the gear
It will
reduction.
heat up. Yeah.
The gear reduction permit that really is stable the position because you need to push a little
Oh,
to
because of the gearing, you don't
yes
have to
the
worry about
gearing
it
help you
moving.
to stay in place.
Yeah, right.
Okay, I put a sensor in front. It's a infrared sensor in front of the robot. I was thinking in the ultrasonic sensor, but you need to ping and wait, and this is only you just make analog read. That's it. It's
A lot faster.
10 microseconds or something. It's fast.
So I'm sorry, the infrared sensor is for obstacles?
Yeah, but it's not connected right now. Okay.
It's futures.
Yes, right.
I am making this robot because I was working in a lot of different ways of location, indoor location, okay? Using infrared, using ultrasonic, using laser. I show different ways of location with experiments. The idea is to use this precise movement to know always where you are inside a location, right?
It looks like from here, does that have one sender and one receiver on the
Yes,
IR? So they're about,
it's a infrared LED and infrared phototransistor.
Yeah.
But this sensor can tell you the distance
Yes.
from
Okay.
from 2 inches to 20 inches. They have different models, different.
Is that a sharp or what is?
The sharp,
Yeah.
yes.
So that's an assembly that's, the angles are preset and so forth.
Yeah.
Mhm.
It's a probably photocopier type sensor.
I think that they use this in a production lines to count stuff.
They use that in all kinds of stuff. Those Roombas that I've got, those robots that we've got,
Yeah.
they're in the bottom of it
Oh, okay.
for
Now-
drop-off sensors.
Let's go back to the.
Keep you from going down the steps or
Yeah.
whatever.
And they're fast. They're
Okay,
fast enough.
now I am.
Doesn't have to be fast.
All of this is made with the original driver board. That's unipolar driving. Okay.
The original
You
driver
can
board that came with
double
the stepper
speed
motor.
and torque if you use bipolar driving. Okay, with the same voltage. And that's what I am trying to demonstrate in this new board. I am using a driver board that is called Easy Driver. But there are a bunch of boards, of different boards that do the same
So
thing.
that's not the original driver that came with it, or is it the original driver?
It's a
that came with the
Chinese
motor?
one. But it's an open source.
Did it come with the, oh, it didn't come with the motor?
No.
Okay,
The motor uses the unipolar drive.
okay.
They are 4 Darlington transistors driving one side of the coil. This driver uses both sides of the coil and apply voltage in one direction or in the opposite direction. And you can.
Do you have to supply 2 voltages to the driver then?
No, it's an
Or does it reverse
driver.
H driver, okay.
Yeah.
Gotcha.
Okay. This one use also 9 volts. Let me use this power. I think I can double the speed with this driver, okay? And maybe I redesign the wheels to be a little smaller and all the robot to be smaller also. Everything is a bunch of experiments and this is an Arduino Nano. This is the speed.
Okay, so that's a Nano you got up there and the driver board up on the
Yes.
screen, same one you got there. Cool.
It's the same board. Okay, I can go faster, but you can stop the movement. If you go faster, you lose torque, and this is a trade-off of torque and speed.
Yeah, I think Ray or somebody was mentioning it, and the original thing is if you want more torque, you can get it, but you got to step the voltage up. You end up stepping
but
the voltage
the
up.
voltage is 9 volts, 9.5 volts, are not 5 volts.
Oh,
The
okay.
original.
You're ramping the voltage up with the speed?
I already increased the voltage and the driving. I'm trying to get the most of the motor with
Okay.
all the tricks I can apply.
So it's overclocking stepper motor, so to speak.
Put over voltage on the stepper motor and he gets a faster step and more horsepower, more torque and all that stuff. Cool.
Does that blow it up earlier? Is that one of the trade-offs? It'll die soon? Is that one of the trade-offs? I mean, you step the voltage up.
You step the voltage up. The thing about it is you step the voltage up, but the pulse widths are very small here. So as the speed goes up, the pulse widths are smaller.
Here I am using a library called Axle Stepper. You can control the acceleration, how fast is the start, and how fast is the braking. Okay.
Okay.
The sample with this one is without acceleration. There is a problem with this library. You can coordinate the movement and use acceleration. There is a limitation of the library. Or you move synchronized, or you move controlling acceleration of one stepper and the other stepper. When you do that, they start at different moment and produce a strange behavior. You know, I will solve that in this design using this differential driver, because the movement of both wheels are exactly the same. Okay, both go forward, or both go backward, or move in opposite direction, or one is moving and the other one is stopped.
Mm-hmm.
Then you can use the same signal of one motor, apply it to the other one, or you can control the direction independently of the library. And just having one motor, controlling one motor, you simulate all the behavior of acceleration. And for example, in this example, I am using acceleration for starting and stopping in the motor. And it's pretty good because you start slow with a lot of torque,
Mm-hmm.
and then go faster with less torque. It's
Okay.
ideally to move something heavy I did it with this, but they move no coordination. They don't make a rectangle. They made some kind of open corners. but the movement is very nice. You know, you see how he slow down, stop, go up. It's not like you see that it's go just jumping all the time.
Okay.
I will combine both things to make it works slowly and strong,
Mhm.
right?
How do you do your move commands? Are they pre-programmed, or do you intend to send those wirelessly?
We can see that the code is very short. This is the code we saw is this one. I will open this with, instead of using Arduino, I will use a text editor. It's faster because the Arduino environment is too slow loading. I can change the size of the, okay. I make the library function is this one. You define two entities, stepper right and stepper left. You do that in the setup of the program. Before the stops, sorry. You define the pins connected to the coils, and you have this is the ASL stepper library creating stepper right and stepper left in mode half step, and the coils are connected to different pins. Then you let me show the setup. You can set the maximum speed of the motor. Here's 1,000 steps per second. You can set the acceleration. You can set the speed. They have the different parameters, the maximum speed and speed. I think that they use it for acceleration, to limit the acceleration. This is the loop, okay. These are my functions. Forward and turn are functions made by me, but it's almost calling the ASL stepper functions. Move. You move to a number, an integer, that represents an amount of steps. You move. In this case, you are saying turn 90 degrees. You move both motors in the same direction. They are turning because this direction for this motor is this direction for this one, right? That's why to turn, you move in the same direction.
Yeah, okay.
If you want to go forward,
That's very clean.
if you want to go forward, you move in different directions, the motors.
Yep.
Okay, plus and minus there.
This library works with a microseconds clock, right? He knows when was the last time I moved one step, and then you go to the function, and the function is in a loop waiting for the time to elapse, right, and to make the next step. The function write down the time of the actual step and again wait for the next time when he needs to move another step.
Mm-hmm.
That's why the movement is practically your program is just moving the motor. It's not for interruptions. You are moving the motors. You are doing anything else. That's why I use this sensor, because you can inside this loop you can analog read the sensor and decide to stop the movement inside. You go forward, but you need to check if something in front of you. Mm-hmm. And in the loop you can insert the analog read of the sensor, and you see a value under 4 inches. Stop, go back, turn, or whatever you want. And you use the the ultrasonic sensor, you call a function ping and wait for the echo.
Yeah.
And we'll wasting a lot of time. And we surely will affect the way it moves. You spending
It
this
usually
time.
does, yeah.
And you
Yeah, it
to
usually
work with
does.
that.
That's one of the things
Yeah.
when I'm using the ultrasonic. I'm always having to juggle my time while the motors are running.
Something, anyone want to see something special? I will continue this when we'll be more refined. I will bring back because I plan to use the different sensors I was designing for location to put in the robot.
Mhm.
For example, the laser ranger I showed.
Mhm.
I bought a ring, a contact ring that can go 300 revolutions per minute, maintaining wire connection between both sides.
Oh, okay.
Just to put the laser over the motor and scan all the room around and draw how the room is. And he knows where he is, and you can decide go to another place.
A
Just
slip
use-
ring, yeah,
use
it's
it.
a slip ring. Cool. That's
I plan to
excellent.
use the
You're gonna map the entire area. You're gonna map everything.
yeah, but you do a map every 5 times per second. All the map
Wow.
turning around.
Now, he's gonna kick some robot ass with this thing. Wow.
Now, how
We
you
will see it in progressing in the program. We will see in the computer the drawing of the room.
He's probably gonna do a matrix and set the bits in the matrix or God knows what.
So is that a laser scanner that you're building yourself?
Yeah. I use a laser and a diode array,
Array.
optical array, and for triangulation you can estimate the distance. This is here in the video.
Yeah, I'm not sure which video it's in. You may be able to find it.
Must be.
It may be way down in there.
I showed this is always something I showed in one of the meetings. It's a blower with air controlling the position of the ball in the air.
Yeah.
I think
It's
was before the.
yeah, it's
Yeah.
way down in there. There's so much stuff going on.
It's a gesture sensor
Mhm.
made with 2 LDR sensors. You can know how you are moving the hand over it, just sensing the edge of the shadow of your hand. You can know in what direction you are moving your hand.
I'm sorry, what is it detecting, the distance of your hand or
No,
whether
it's
it's in?
no, you can
Whether
put
there's
your
a
hand
finger there
anywhere.
or not.
It used the shadow of your hand.
Whether it's covered or not, whether it's covering the light or not.
Well,
It's like a gesture,
it's a gesture.
Just, okay, I see.
so you could set it up to swipe something across the screen
Okay.
or
This is the kind of signals you see. If you move in one direction or in another direction, this is just one finger in one direction. This is the finger in another direction.
Yep.
And this is 2 fingers in one direction, 2 fingers in another direction. All of them are different signals. And you can use the Arduino to identify what you want to do with your hand moving over. For example, I was thinking in a robot that has this sensor over it, and you are in your backyard or somewhere, and you tell him what to do with your hand, just moving your hand over it.
wave your hand.
I didn't.
these are not the robots you're looking for.
Right.
I made the state machines to design the software, but I jump in another project immediately.
Yeah, the laser thing, that was a while ago.
Yeah, maybe I have the thermal laser detector. Was not the laser detector, right?
Yeah.
This is one of the projects I show here. It's a laser detector made but for under $1 because he found a laser. I told him, okay, I can do it for under $1.
Wow. So you have a laser and then you have the array. Is that?
This is another project. It's not,
Yeah.
you know, the Ranger. This is a,
Okay.
what is this?
Who wants to download a new
No.
version?
This is,
So what's this? This is, he's got numbers written and the laser is scanning back and forth and it can put the, on the screen it's reading and it displays more or less what the numbers are representing.
this is the sensor for under $1. It's a laser with a phototransistor, a photodiode. It's showing how it detects
I see.
the black and white parts of a paper.
Okay.
And then later he did it where it actually
Scan.
makes the circle and the one and
I don't know. Maybe
it looks like it,
here. This is.
Okay.
it looks like it should.
There's
Look.
both of them in one, laser and sensor.
This is the parts using a pen and.
I found one that was about $10.
This is the laser detector. Okay.
And his is better.
There's a prototype before he got it on the servo.
This is showing how we detect white
White and black.
and dark, light and dark places in the. Okay, this is the till and pan servos to move it. Let me check. Maybe it's here the video. I don't know. No, I don't see it.
I don't know.
Now, this is not on the club website, right?
Some of this is in the folder. Some of it's,
Sí, many of this, yes.
much of it is on the Vicente's folder. He's got a folder. Go to your meeting announcement if you ever get one. And go to Vicente's folder and you'll get it.
Okay.
This is the laser Ranger. Okay. This
I
movie
don't
out
know.
now.
So-
I guess I should see what's in my Gmail account.
This is
because I don't
the
get that
laser
trouble.
Ranger. Is the detector and the laser. Laser cost 50 cents from Amazon. And the
These are visible lasers or IR
yes,
lasers?
red laser, red.
Red laser of some sort? So this would be the kind of laser that's in a laser pointer or whatever then?
I have. Go.
Yeah, Amazon has become the existence test for any
Okay.
product.
Yeah, this is how it works. Okay, I put
Yeah.
this is an array of sensors.
Yep.
Inside a tiny box made for 3D printer, and the Arduino read all the sensors in
How many
the row.
sensors are in?
64.
64?
But I am using the center of mass of the shape of the light.
Yeah.
And you have a lot of resolution with this. Just seeing how it looks. find out the center of the shape of the laser.
But that would be very quick.
Here's the how it looks in the computer using processing to show the data. And you can find the center or the position of the laser in the sensor. From using triangulation geometry, you can estimate the distance. And we made experiments here to see how it works. 64 sensors, but the resolution is higher.
So you said this could go from 2 inches to how long? The range,
The range was 2 meters or 3 meters.
3
distance.
meters from what to 3 meters? What's the minimum, what's the maximum?
Meaning 4 inches. When you are close, it's a matter
Like,
of changing the angle and the
Like 10
distance.
centimeters to 3 meters, something like that, is that what you're saying?
This is the experimental curve for the equation of fitting. I use from maybe 5 centimeters to 125 centimeters in this
Okay.
configuration. You can change the distance between you can move this sensor to another distance and increase the sensing.
Got it.
Did you draw all of this?
Excuse me?
Did you draw all the diagram?
Yes. I draw everything all the time. He knows.
Effort.
He's got it all documented, all of it.
Before I draw, before I go to the table to see, I always draw everything. I have thousands of drawings and schematics and everything.
Saves a lot of false starts.
So when you revolve the laser detector, how will you rotate that? With the
Okay.
motor, is that a stepper motor or?
I bought from China an adapter, a couple that pass 6 contacts between one side to another and permit 300 rotation per minute. Okay. You will have in the upper side the assembly of the laser.
Yes.
Underside you will have a optical sensor to know the position of the rotating device.
Yep.
You can slice in time the rotation, or you can use a stepper motor to know exactly where are you pointing. I didn't solve that yet, but
And I'm sorry, how fast do you intend to revolve that? 5 times?
5 times per second, no faster.
No.
Five times. I need to change the sensor, the optical array, to go faster.
So you're making your own LiDAR?
My own what?
Yes.
LiDAR, light emitting, light, something LiDAR.
Like radar.
Like radar with
except
light.
for light.
Yeah. Like that. Okay. But if I see in writing form, I say, okay, I know what you're talking about.
Oh, yeah, no,
Or
it's
hearing
funny,
it.
it's, yeah.
Yeah, exactly. But I was planning to use, I made some experiments 2 months ago using IR signals from a TV, the infrared transmission of 40 kilohertz signals,
Okay,
using a black box with a very narrow slot,
yes,
with the sensor inside this, and you have like a beacon
yeah,
sending the signal in some, and you move it and finding the angle exactly where it is, and the result is very promising to use it. It's very cheap also to move the sensor and to have 2 beacons in the room, and for triangulation you know exactly where you are all the time. For a robot, for example.
so it would be a way for the robot to know where it is.
Yeah.
By virtue of the 2 beacons.
Yeah.
And their angle.
And the other thing I am working on is ultrasonic distance. I send a radio signal with a code and a burst of audio signal, very high frequency, both start together and arrive at different time to the receptor, and you can find the distance from the beacon to the, and it's working pretty good. I did 50 meters with 1 centimeter of precision, you know, very precise, very easy. Maybe also a good thing to, my initial project is to design a virtual fence for the dog. You know, in the dog
Don't call it.
will be the sensor, and you design the shape of the path of where you want to dots and crows. Okay, using circular coordinates, using 2 beacons that produce waves in a circular shape, where the waves intercept the dog. You can know exactly the position of the dog in the backyard or whatever, and it works very nicely, very.
So, I'm sorry, with the dog, was that ultrasonic also?
No, it's in the audio range.
Audio range?
It's 18 kilohertz, but during 1 millisecond.
Guys, that's ultrasonic.
1 millisecond. It's very narrow. It's just a pulse. It's a pulse.
Yeah, gotcha.
I designed a receptor for that.
So it's like a time of flight?
Yeah, but you know when it started, because the radio signal arrives instantly, and the audio signal comes later, and you estimate the difference.
Okay.
And you have a resolution 1-2 centimeters.
Okay. Yeah. Good.
It's very cheap, and it works. I was working until 15 meters.
50?
50.
Yeah. Wow.
I'm changing the amplifier, and I bought several tweeters, the car audio tweeters.
Mm-hmm.
I am planning to change the tweeter for a solid tweeters. It's not it's ceramic tweeter.
You're talking about piezoelectric tweeters.
Piezoelectric, yes. No. And to increase the power and to go for. I was thinking you can use it to know where your players are in a field also. Mm-hmm. You can do a lot of things with that. My initial design was you can only have 1 sensor in the field, but with this new approach, you can have thousands of sensors, because each one are receiving the pulses periodically and calculating the position.
Yeah. So I'm very interested in something that would detect a direction of an object and also its distance.
Yeah.
The orientation and distance. I'm very interested in that.
In this case, the orientation, you don't have the orientation, you have the position. In this case, when you are in a single position, just hearing, you know where you are, but you don't know where you're facing. If you move, and you know how much you move, you can calculate the angle of this movement and know where you're facing. So it's a more dynamic estimation. You are quiet, you don't know where are you heading. Need a magnetometer or a compass, electronic compass or something. Another experiment I'm making, I bought two very high resolution GPS, and I'm trying to have both GPS working at the same time. I know the exact position of the fixed GPS. I have the data of the both GPS, and to correct the position to have a resolution under 3 meters. I still waiting for.
So have you looked at
to have time for that?
RTK? Have you looked at RTK solutions?
It's called differential GPS. Differential GPS used in aviation for landings.
Okay.
You have a a device in a fixed position in the field, and the plane has another device that is asking the other one, where are you? And it's correcting all the time the position, because for some reason, the military or something, they are sending random position around 3 meters usually.
About 3 meters. I investigated that quite a bit. So, I mean, a lot of the precision GPS, they claim, like the company Trimble.
Uh-huh.
So, I mean, from Trimble, you need a receiver that's maybe $10,000.
Mm-hmm.
And it needs corrections either from a equator revolving satellite or from a base station.
Yeah.
And-
Ohio have base stations for correcting this data.
Yes.
I was investigating. I don't know if they are free.
I don't know either. You can buy your own base station, but it's a certain amount of money. But basically, there are two things that the RTK solution relies on: not the information from the satellite, but it attempts to discern where you are on the carrier frequency.
Okay.
The carrier for GPS L1, I think, is 19 centimeters.
Okay.
So
yeah, is the shorter distance you can.
Yeah, and so if you have a base station, and let's say it's your own base station and it's only at the other side of the building.
That's what I intend to do with 2 GPS, but I don't know if it's possible.
Well, it takes a while to establish the corrections when you have your base station. So this is done quite a bit. Trimble does it for agricultural equipment.
Yeah.
And also for surveyors. And then they would use the state of Ohio base station.
But they are very expensive
they're very expensive. Yeah, you're right. And when Trimble sells you a subscription for the corrections,
for the service, okay.
that could be $2,000
Wow.
a year. Yeah. So I mean, if you're a surveyor, that's nothing, or if you have a big agricultural operation,
You need to apply in a business that pay by itself.
Yeah, but for small companies or individuals, it's prohibitive. But they are coming out with better RTK solutions where they attempt to find out where you are on that little 19 centimeter.
Yeah.
And so one good company that well, the other thing that the base station does is GPS has an ionosphere delay.
Okay.
That's unpredictable day to day.
They change it.
But if you have a base station that's nearby, you're both receiving the same delay, so that cancels out. So that's a big part of the solution for getting precision GPS is to use the carrier wave. And then the main thing of it is they have integer ambiguity, because you don't know which wave you're on.
Exactly.
And the solution with the corrections attempts to narrow that down so that you know exactly which. Yeah, and then you can get centimeter level accuracy. So Trimble, very expensive, but they say they can get within 4 centimeters.
Yeah, wow.
And then Novatel is another company. They're from Canada. Novatel is another company.
I saw several projects about to sell low-cost devices for using this technology. Some guys are planning to sell for under $100 one device to do that.
Okay.
But I think they are using some kind of recon. They estimate your movements using accelerometers.
Yeah, so they have an IMU.
For instant calculation.
Right.
Then they average. I don't know exactly again where it is, but when you move fast, you use just accelerometer for integration algorithms. You know how much you move quickly, and then you adjust in time the position again.
Right. Yeah, that's
it's very, very complex stuff.
But that is the thing of the future, to be able to combine the IMU information with the GPS information. And so there is a company that I know of, Swift Navigation. They're in San Francisco.
Yeah.
They're attempting to make a lower cost solution, but they are not quite there yet. They're also working with the robotics company to combine the IMU.
I think that this technology of self-driving cars will introduce a lot of new stuff and redundancy in this technology of satellites and laser rangers and all this.
So the self-driving car that I rode in a few weeks ago in the parking lot, of course, they said they used Trimble. And another company, I try to stay in touch with them by email. They're called Autonomous Stuff.
Mhm.
They're in Peoria, and they use Novatel.
Yeah.
So the guy from he said that for me to use a sensor, a receiver like that, it would be $15,000.
This would be a good collaboration for Google Plus.
Oh, but that's I've been researching it a lot. I've purchased 2 evaluation kits.
Okay.
One is from a company in Taiwan, and the other one is called SkyTrack with a Q at the end. And then the other one is uBlocks, which is a Swiss company, and that's spelled the letter U, BLOX. They also have an office in Northern Virginia.
Okay.
And they were at that conference, but they sell an evaluation kit for $400. It has 2 boards, a base station and a rover, and it has a radio link for $400, but we have not had good success with it, even in what we thought was an open sky. So
I'm thinking in a very low cost approach to design devices for different situations. For example, you have a very old man and house, and he has a device, and you need to know that he is in a radius of, I don't know, 100 feet, and he go out, you have a signal or something, hey, where are you going, or anything else, dogs, and you can go to a park, for example, with a stick, with the bacon, and put it in any place, and your dog will be around the stick, whatever, 50 feet, 100 feet. But this
And he gets a warning if he gets close to
it's
it.
for consumer
You're shocked
market.
if he gets.
well, I mean, if I could get for low dollars within 4 centimeters, then my
Yeah.
problem's solved.
Yeah.
Well,
But I'm
if,
afraid we're not
if
there
they ever
yet.
come to that,
Right.
I mean, the whole market's gonna be flooded with stuff, seriously. Because I'm gonna be building stuff.
Yeah.
My trash can transport will be next day.
It'll be on the road.
Yeah.
I spent the last 35 years of my life designing products. And now I am retired, but I have a thousand of ideas of everything. And every day I'm doing things and sending this stuff to other companies to evaluate, and
So you're retired right now?
I'm planning. I
Oh,
have,
you're
I have
planning.
several companies still.
The, one of the things I ran into this week in I do video camera stuff. My Shricam, which I've been pushing around here, the Shricam just came out with a SR0019, I think it is they had the 12, this is the 19, and it's a 1080p resolution, and the frame rate's rated at like 15 instead of 30, but it's $60, and you've got a significantly higher resolution. And what that means to me is it's mainly just phone.
You have some kind of
You
Frankenstein
can zoom.
surveillance system,
Sir?
mixing everything.
It uses the same software,
Yeah.
apparently, just different frame rate. And what this means is you can zoom much more and like better shot at a license plate or something like that, and better zoom. That's for about $60. I may get one of those just because.
Yeah.
I already got another one. I already got a low resolution, 720, another one on order at $30. The Arduino Foundation, I put a link to the Arduino Foundation in the newsletter. You guys can go to the newsletter.
This is this is the sensor, right? I made a small camera using the 3D printer. It's a pinhole camera without lens, just a hole in the top.
Yes.
and the laser just pass through the hole to the sensors.
To discern what the angle is? I missed something, I'm sorry.
No, I am not using lens. I am using a hole, a very tiny hole in the camera.
Okay,
Okay, and you can see only one point of the image.
your field of view is
Yes,
a line.
Instead of using a lens, I'm using a hole.
Yeah, okay.
It makes the device slow because you need to wait for the light to integrate the sensor.
So the expectation is that a beacon is out
You
here.
want to go fast, you need a lens to acquire quickly the different pictures.
Did you drill the hole to make that, the hole? Did you drill it?
I drill, yes.
Okay. I was thinking that with 3D printer, it wasn't going to come out.
0.8 millimeters.
Okay.
I don't know if this here is this is the originally this IC came in a different package. The old one, the new one is a surface mount. The first experiments was made with the deep
So this is a linear array or a square array?
linear array.
Okay.
64 sensors in alignment. Originally, this is the kind of drawings I always make. Okay. This is I also was playing with a very cheap camera, $2 camera. This is Arduino taking pictures from using a very low cost camera.
Did you ever publish that code anywhere?
No, it's a little full of comments. It's heavy. I need to clean a little bit the code.
Well, the comments are great. That way you.
No, but it's all the experiments. I write code,
Yeah.
quote, write code, quote, right? And then you have full of code,
Oh.
full of quotes, and
So you got everything you tried, basically.
Yeah, the code grows and grows and grows.
That's, he's one of the very few people that have gotten that cheap $2 camera to actually do something.
This is I made a program in the computer, and the Arduino sent to the computer the images in different resolutions. But look at the speed. This is an Arduino Nano sending 3 images per second. It's very slow, right? But it's an Arduino. It's serial communication. And then I made experiments detecting colors and the position of the color in the screen. We show here how to follow a ball of different colors using the Arduino.
When you Google that particular camera, though, you don't find very much information and/or people actually making it work.
If we can culture Vicente into publishing his code, like today would be a good day to, the demonstration you did with the square dancing thing, going in a square.
This is the Arduino sending images and detecting the green color, for example.
It's about 10 till, just so everybody knows.
So a lot of stuff.
Vicente, are you intending to sell your sensors, or how do you?
I don't know. I don't know. Maybe well, if I see an opportunity of cost and maybe the people really like it, for example, maybe. I know about the electronics design, and I always buying new sensor from Mouser or different companies send me new sensors. Now I bought a whole effect sensor to sensing magnetic fields in three dimensions. I'm thinking to use it to detect the position of a wheel, to put a magnet in the center of the wheel, and use the sensor to know the direction of the field and know exactly the position of the wheel for a road. But I had no time to follow. I had the sensors and another sensor and another stuff, and another stuff is coming, and I'm traveling every 2 weeks. I am going.
You had a real
I have
time.
no time.
Anybody have anything for next week? Any want to do a demo next week? Anything you want to show? Okay, I warn you, you're gonna get trash can transport next week.
Maybe I bring
that
the.
project?
Yeah.
Why don't you just hire some kid in the neighborhood
See,
to haul a trash?
this is an effective tool for me, because if they don't come up with a project by next week, they get trash can transport. And they know it.
Is that an incentive that?
That's incentive.
You want to do something with that next week?
Okay,
That is nowhere near close to being even partially done. It goes around in a circle right now.
okay, so
That's a little laser cut robot.
Okay.
Little
Got
Thing.
2 eyes.
What is the material?
MFD, MDF,
Which is
MFD.
it?
I don't know.
MDF.
Multi diverse
wood chips.
MDF.
wood. It's wood fiber.
Yeah.
Is the one with the smiling face?
Yeah.
This one, okay.
So where did you get the laser cutter?
Well,
Middletown Library.
no, I went to Miami University, MUM in Middletown. They've got a laser cutter, and pretty much you bring your material, you can.
Without appointment?
There's also another gentleman who's not here today. He actually owns a laser cutting business that if you ever could catch him.
Yeah.
Yeah, if you ever needed
If
some
you can
serious
catch them
laser
on the
Have you
cutting.
ever heard of a place called Hive 13 down on near Spring Grove?
Yes.
That's where Steve is a member.